Hello class, welcome to another lesson. Today's learning goal is I can simplify radical expressions. Okay, radical expressions are just any expression in math that has either a square root, a cube root, okay, or a fourth root. There's even that. There's an infinite amount of these, and we'll learn more about these later on in the year. But so for example, the square root of 4 is 2. The cube root of 8 is 2. And the fourth root of 16 is 2, because 2 times 2 times 2 times 2 is 16. But it's any one of those sort of things. So we're going to simplify it, and what that means is we're not going to look for the value of it close to the 10th place. Instead, what we're going to do is learn how to write it in a mathematical way. Okay. And I'll show you what that means in a moment. But in order to do this, we need to remember what our perfect squares are. So let's use white. I like white. So the perfect squares are, again, 1. Be sure to write these at the top of your notes. 1, 4, 9, 16, 25, 36. Here, the 6 times 6, 7 times 7 is 49. 64, because that's 8 times 8. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. 144. We'll go a little bit further. 169. And 196. For kicks and giggles, 225, because that's 15 times 15. So this is 13 times 13 right here, 14 times 14, and 15 times 15. So let's go ahead and get started. So we're going to rewrite the square root of 45. And how we're going to rewrite it is that in square root of 45, there is a perfect square over here. That goes perfectly into this number. Okay, what is that perfect square? The perfect square is 9. So I'm going to rewrite this as. Yep, we got that. Yep, good. We're good. The square root of 9 times 5, because 9 times 5 is 45. Now the rule is, if we have a number that's square root of AB, this is also can be rewritten as the square root of A times the square root of B. Okay, and I'll show you guys that in a moment using some more common numbers. But here, this can be split up then into, according to that rule, the square root of 9 times the square root of 5. Okay, and the square root of 9 is 3, so this is 3 times the square root of 5. Alright, to prove that this rule right here, which is important, works, I'm going to use two perfect squares. And so for example, A is going to equal 9 and B is going to be equal 16. And the square, 9 times 16 is 144. So the square root of 144, which we know is 12, is 12 because 144 can be split up into 9 times 16, which can then be split into square root of 3, or excuse me, square root of 9 times the square root of 16, which gets us 3 times 4, which we all know is 12, and we all know that the square root of 144 is 12. Okay, so this rule does work, and we can simplify parts of it, some of the factors of 45, by finding out what perfect squares go into 45, splitting that up into those two factors, and continuing on. Here, because 5 is prime, or excuse me, 5 is not a perfect square, or no perfect squares can go in 5, we are done. Okay. Where this comes from and why people have it out there is because let's say a farmer wants to create a square plot of land that has a total of 45 square miles. Okay. Instead of finding the decimal form of square root of 45, I don't know what that is exactly, but we'll say it is 6.5439. It goes on and on and on and on forever because it's a irrational number. Instead of doing that, they simply are going to write the length is going to be this 3 square root of 5, and the length is going to be 3 square root of 5. Okay, that communicates it a lot easier. I'm going to make that look a little better. That communicates it a lot better than that was off. If we were to do the decimal form of it, because it just goes on and on and on and on forever. Okay, so that's where it becomes useful in actual using of irrational numbers. You want to give the simplified version, not the square root of 45. Okay, so let's try this one. Square root of 60. So we need to think of a perfect square that fits into 60, that goes evenly into 60. So it's going to be not 36, because 36 times 2 is already bigger than this. So it's going to be, I believe, 4 goes into here. Yes, 4 does. So we're going to rewrite this as the square root of 4 times 15, because 15 times 4 gets us 60, which then splits up into the square root of 4 times the square root of 15. And the square root of 4 we know is 2, so that's 2 square root of 15. This right here is the square root of 15 is the simplified version of the square root of 60. So this is our final answer. This one is slightly larger. We're going to split this up into we look at our list. 121 goes into this, and it goes into it twice. So this is the square root of 121 times 2, which splits up into the square root of 121 times the square root of 2. Square root of 2, obviously can't do that, so it's just going to be 11 square root of 2. No other perfect squares fit into here except for 1. And so we're going to move on. This is our final answer. Let's take a look at this one. This one, 4 goes into this one as well, because as we know with our divisibility rules, 20 means, this 20 right here means that it's going to be divisible by 4. So let's do square root of 4 times, this is going to be 80. Split that up into square root of 4 oops, sorry, did not want to do that. Square root of 4, gotta get the pen back. Square root of 4 times the square root of 80. Gets us 2 square root of 80. However, we are not quite done yet, because another perfect square can fit into this. And that perfect square is 4 again, or we can think a little bit larger and realize that 16 fits in there as well. So the 80 becomes 2 square root of 16 times 5. Which means that we need to continue on. So just because you found one perfect square that goes into it doesn't mean that there aren't more. And I'll show you how to continue going on from here. So we have 2. Remember, this is times the square root of 16 times the square root of 5. And that becomes 2 times 4 times square root of 5, which becomes 2 times 4 is 8. Square root of 5, and 5, there are no perfect squares that fit in there, so our final answer is 8 square root of 5. Okay, So the key point in here is that just because we get to this point right here doesn't mean we necessarily stop. Each one of these previously we could stop because square root of 2 had no perfect squares that can go into it. Square root of 15, 15 had no perfect squares to go into it. And same thing with this 5 right here. So we could stop there. But here, 80, there's a perfect square that goes into it. 16. We can do this multiple times sometimes to get our final answer. So go ahead and pause the video and try this one out on your own. So let's try this together now and see what we get. So here we have 448, square root of that, and this 48 tells us that 4 goes into it. So we're going to split this up into 4, square root of 4 times 112. So square root of 4, 4 goes into this times 112, which gets us square root of 4 times square root of 112, which gets us 2 times square root of 112. And we look at the 112 and see with this 12 right here, that 4 goes in there again. So we're going to split that up into 2 times square root of 4 times, it's going to be 25, 26, 27, 20, nope, not 27, 27, 28, 29. I think that's right. Not 29, 28, excuse me, 28. No, what is that? 5 times 4 is 100. 4 goes into 12 3 times. 28, yes, 128, which gets us 2 times square root of 4 times the square root of 28, which then gets us to 2 times 2 times the square root of 28, and let's make this a little longer. That gets us to 4 times the square root of 28, but we realize that 4 goes again into 28, so we get 4 times, I'm just going to skip a step here, square root of 4 times the square root of 7, which gets us 2 right here, which makes it 4 times 2 times the square root of 7, which gets us our final answer of 8 times the square root of 7. That's our final answer because the square root of 7, 7 has no perfect squares that go into it. Go ahead and try this one on your own. Here again we got this 52 part right here, which tells us that 4 goes into it. So let's do this and change it to square root of 4 times 252. 4 goes into that. That's 50, 60, 63 times. I believe that's correct. 63 times 12, 12, carry the 1, 24, 25. Yep, 63 times. So then that gets us 2 square root of 63. Oops, of 63. Okay, and we're not done yet because 63 has a perfect square that goes into it, and that is 9. So we got 2 square root of 9 times, 7, which gets us the 2 times 3 times the square root of 7. I'm skipping a few steps here, but 2 times 3 is 6. Square root of 7. 7 does not have any perfect squares in it, so our final answer is 6 square root of 7.